Hello, so in this video we're going to talk about functions of two variables, x and y, and we want to talk about how to compute partial derivatives of functions of two variables, x and y. So we've got two different approaches, number one and number two down below. For number one, to find the partial derivative of f with respect to x, pretend y is a constant and take the derivative with respect to x. Here's what I mean. Consider an example, f of xy equals x squared plus y squared plus sine x. We want to find df dx. In other words, we want to find the derivative of f with respect to x. So x is our variable. I'm going to underline all the terms with the x in it so that I know that's my variable. Everybody else is like a constant. Like you could pretend in your head that instead of y squared that this is just some constant like 3 squared. Alright, let's do our derivative. So the derivative of f with respect to x, well, derivative of x squared is 2x. The derivative of y squared is going to be 0 because that's acting like a constant. And the derivative of sine x is cosine x. So our final answer is 2x plus cosine x. Now, on the other hand, if you want to find the derivative of f with respect to y, you pretend x is a constant and take the derivative with respect to y. So this means y is going to be our variable and everybody else is like a constant. So to find df dy, again, everything with y, that's my variable. That's what I'm going to really hone in on right now. So the derivative of x squared, well, x is playing the role of like a constant. This is like 5 squared or something. And over here, this is like sine of, pi or whatever it is. So when we come in here and we take the derivative of x squared, it's just like a constant. So the derivative is 0. The derivative with respect to y of y squared is 2y. And lastly, the derivative of sine x is going to be 0. Again, x is acting like a constant. Final answer here is 2y. Let's do some more examples. So for the next example, I'd like to look at f of xy equals x cubed plus x squared times y cubed minus 2y squared. And for this problem, let's find the partial derivative with respect to x and evaluate it at 2, 1. And let's find the partial derivative with respect to y evaluated at x equals 2, y equals 1. Okay, so first of all, to find the derivative with respect to x, well, x is like our variable, everybody else is like a constant. So you can imagine, that you've got an expression x cubed plus x squared times some constant. I don't know what the constant is. You could pretend it's like a 7 minus some other constant like 8. Right? And how would you do the derivative of this sort of function back in Calc 1? You would tell me that the derivative is 3x squared plus, let's see, bring down the 2 times 7, that's 14x minus 0. That's what you would have told me back in Calc 1. So let's do the same thing here, Calc 3 style. We're doing a partial derivative with respect to x. We're going to differentiate with respect to variable x. So we have a 3x squared. Over here, the 2 comes down in front times this constant y cubed minus the derivative of 2y squared. But that's just like a constant, so that's going to be 0. Let's evaluate at x equals 2, y equals 1. And when we do that, we get 3 times x squared, which is 2 squared, plus 2 times 2 plus y cubed. Y is equal to 1. And when we work this out, we get a final answer of 16. Okay, now let's turn around and do the partial derivative of f with respect to y. So now the x's act like constants and y is like the variable. Alright, so we go through and the derivative of x cubed with respect to y is 0 plus, bring down the 3, so we've got 3x squared y squared minus 4y. Evaluating that at the point x equals 2, y equals 1, we're going to have 3 times 2 squared times 1 squared minus 4 times 1. And that equals 8. Okay, I'd like to do a few additional examples. Number 2, let's consider the function f of xy equals sine of x over 1 plus y. Now another way we could write this is sine of x times 1 plus y to the negative 1. And there is some advantage to doing that because to do this derivative on the inner function we'll need product rule, whereas over here we would have needed quotient rule. And in general, product rule is a little bit easier to work with. But either way, you should get the same answer. Okay, so let's start off and find the derivative with respect to x. So we will need the derivative of sine, which is cosine, times. Okay, so let's find the derivative with respect to x. The derivative of sine is cosine, and I'm going to copy over the inner little function, which is x over 1 plus y, times, here we're applying the chain rule, times the derivative with respect to x of x over 1 plus y. Okay, let's keep going. Copy down what we had. We had a cosine of x over 1 plus y, and according to the chain rule, we still have some more work to do. So we need to do a derivative of a quotient, so we'll use our quotient rule. The derivative of the numerator times the regular denominator minus the derivative with respect to x of the denominator times the regular old numerator all over the denominator squared. Okay, and this right here is our quotient rule. Let's clean this up and actually go in and take those derivatives. So we have cosine of x over 1 plus y. That didn't change from any of these lines up above. And now we've got a lot of work to do here. Let's see, the derivative with respect to x of x. That is just 1, right? The derivative of x is just 1. I'm going to circle that just so we know where that came from. Times the regular bottom, which was 1 plus y, minus the derivative with respect to x of 1 plus y. Well, this is just acting like a constant, so that's 0. And 0 times x is 0. All over the denominator squared. Okay, cleaning this up one last time. So we've got cosine of x over 1 plus y. And right here we have 1 plus y over 1 plus y squared. This simplifies to 1 over 1 plus y, and a nicer format to express the final answer would be to pull that factor out in front of the trig function 1 over 1 plus y times cosine of x over 1 plus y. Okay, now let's go back through the same problem and find the derivative with respect to y. So I'll rewrite the function here. Our original function was f of xy equals sine of x over 1 plus y. And now let's go and find the partial derivative with respect to y. Well, once again, this is a function composition, so we need to use chain rule. Derivative of sine is cosine, copy over the inner little function, times the derivative with respect to y of this inner function, which is x over 1 plus y. Copy down cosine x over 1 plus y times, here comes our derivative, we'll need quotient rule here, the derivative with respect to y of x times a regular old factor 1 plus y, minus the derivative of the bottom times the regular top, all over the bottom squared. Cleaning this up a bit, we've got cosine of x over 1 plus y times the derivative with respect to y of x. Well, when we're doing partial derivatives with respect to y, x plays the role of a constant. So this piece right here is just going to be 0. And 0 times anything else is 0. Minus, now the derivative with respect to y of 1 plus y is just going to be 1. Times our regular old x, so we get 1x, all over the denominator 1 plus y squared. And again, it's really good form to bring that out in front, so bring your factors out in front of the trig functions. We've got negative x over a 1 plus y squared times cosine x over 1 plus y.